Assalamu alaikum, dear students. I am Hasnia Zahra. Today we will discuss very important topics of chapter number 13, electroscope and electric potential. First of all, we will discuss electroscope and then we will discuss electric potential. First of all, we will discuss the construction or different parts of electroscope. Electroscope consists of a glass jar, brass disc, and a brass rod which pass through an insulator to fix in the glass jar. At the end of the brass rod, there are very thin leaves of gold, and these two leaves of gold are easily movable. A grounded aluminium foil is used for grounding purpose. This protects the electroscope from external disturbance. And the leaves can easily diverge and collapse. In order to use the electroscope for detecting the presence of charge and object, we will consider an uncharged electroscope. We will bring the body near the disc of an uncharged electroscope. If there is a divergence in the leaves, it will show that the test body has charge. If there is no divergence, it will show that the test body has no charge. Why the leaves will diverge and we say that the test body has charge? Due to electrostatic induction, the like charges will move towards the leaves and the unlike charges will gather at the disc. Due to the presence of charges on the leaves, and leaves can easily movable, so they will show divergence when we bring near the disc a charged object. Electroscope can be charged positively with positive charge and negative charge by electrostatic induction method. So first of all, we will discuss that to charge an electroscope positively, we will bring a negative rod close to the disc. When we bring negative rod close to the disc, positive charge will appear on the disc and negative charge will appear on the leaves and the leaves will diverge due to electrostatic induction. So to make the whole electroscope, disc and leaf to have positive charge, we will ground the disc of the electroscope. So the negative charge of the leaves will take an easy path and moves towards the ground, and the whole electroscope will have positive charge. Now we will remove the rod and ground connection and we will have an electroscope with positive charge. In the similar way, we can also charge electroscope with negative charge. So if we create a negative charge on the electroscope, it means that negatively charged electroscope, we will use a positive rod and keep near the brass disc, and we will use the same method to charge the electroscope, ground the brass disc, and the charges from the ground to move towards the electroscope. Electroscope will have negative charge. Now we will remove the rod and the earth connection. Electroscope can also be charged by direct method that is called charging by conduction. In case of charging by conduction, if we want to charge an electroscope with positive charge, we will take our positively charged rod and touch with the brass disc. The electroscope will have positive charge, and if we touch it with the negative charge rod, it will have negative charge. So the charge will transfer directly towards the leaves, and the divergence of leaves will show that now electroscope has some charge. Electroscope can also be used for identifying the type of charge. For this purpose, we will use a pre-charged electroscope, for example, positively charged electroscope. We will bring the object close to the disc, and the leaves of the electroscope, if diverge more than the earlier, this will show that the electroscope has positive charge and the object also has positive charge. Why the leaves diverge more? Because due to electrostatic induction, more charge is repelled towards the gold leaf and the divergence will increase. And if the divergence decreases, this shows that the object has opposite charge, it means it has negative charge. So why the divergence decreases? Due to the presence of negative charge on the object, more charge will be repelled towards the disc and attracted by the negatively charged object, so the divergence will decrease. Electroscope can also be used to test that whether the object is conductor or insulator. For this purpose, we will touch a charged electroscope whether positively or negatively with the test material. If the leaves collapse, this shows that material is a conductor. Why the leaves collapse? The charge of the electroscope will transfer to the test material due to conductor. And if the leaves neither collapse, neither further diverge, the material is an insulator. Now we have completed this topic of electroscope and its purpose for charging and testing insulator or conductor or net charge. Now we will discuss the next topic, electric potential. Electric potential is very important concept in static electricity. For discussing electric potential, we will take the help of the previous concept of 9th class, that the gravitational potential at a point in the gravitational field is actually the gravitational potential energy of a unit mass placed at that point. Similarly, in view of electric potential at any point in the electric field is the electric potential energy of unit positive charge placed at that point and bring that charge from infinity. So now we will discuss what is the meaning of infinity over here. A test charge which is out of the field of the source charge, that position is infinity for the test charge. And the formula, we can discuss that V is the symbol used for electric potential, and the amount of work done in bringing a unit positive charge from infinity to a point in a field. So we can write the formula V is equal to W over Q. The unit for W is joule and the unit for charge is coulomb. So the unit for the volt is joule per coulomb. In SI unit system, we consider its unit as joule per coulomb and it is a scalar quantity. How we can define the SI unit of electric potential, which is named as volt? If 1 joule work is done in bringing 1 coulomb positive charge from infinity to a point, but keep in mind that the work done should be against the electric field. The electric potential at that point will be 1 volt. So from this figure we can say that charge particle from infinity to that point, work done by moving a charge particle from infinity to the other point is electric potential. In this figure we can see that we have two charged electric plates, positively and negatively charged electric plates. Positive charge plate is considered as at high potential and negatively charged plate at lower potential. Now we will observe the motion of two charges, positive and negative charge, between these two plates. We know that according to the definition of electric intensity, the positive charge, which is test charge, always move in the direction of field, and field lines always emerges from the positive charge and end on the negative charge. So these are the vertical straight plates. So we have straight line between these high potential and low potential. We will place a positive charge at a point. It will move from high to low potential. So during this motion, it will give us some energy. It means we have ability to take some utilized work when a positive charge moves from high potential to low potential. But if a negative charge moves from low potential to high potential, similarly it will also give us some energy. On the behalf of that, in the opposite way, if a positive charge moves from low to high potential, we have to do some work to move from low to high potential. Similarly, if a negative charge moves from high to low potential, we have to do some work. It means that we have to give some energy. So now we will discuss that the work done per unit charge to move a positive test charge from one point to another point is called, in a field, is called potential difference between that two points. So now we will discuss some points of electric potential and potential difference. Electric potential is the work done per unit charge to bring the charge from infinity to a point in an electric field, but potential difference is simply the difference of electric potential between two points in an electric field. Electric potential is defined at a point, but the potential difference is defined the difference of electric potential between two points in a field. The units both have same units, both are scalar quantity. Electric potential is zero at infinity, but we can't consider the concept of potential difference in the similar way. It will be zero at infinity. So from the conclusion we consider that if a positive charge moves from a high potential to low potential in an electric field, it gives us some energy. It means we can take a useful work from that energy that is supplied by the charge. Against the direction of the electric field, it means if we want to move a positive charge from low to high potential, we have to give some energy. So according to the definition, we will discuss that potential difference. We can say that the energy supplied by a unit positive charge as it moves from a point to the other point, we can say that from a high potential to low potential in the direction of field is equal to the potential difference between 2 points, but keep in mind that the charge should be unit charge. In that case, the energy supplied by the charge will be equal to the potential difference between 2 points. So now we will have discussed in details. The main key points are repeating again. A positive charge always in the direction of the field and give energy, and this energy is utilized in doing some useful work. When it moves against the field direction, energy would have to be supplied to it.